Mr. Todd's Perfect Guide to Factoring. It's taken me 23 years to refine this into a nice process that you can go through, and any factoring question up to the end of grade 11, you can just look at and go, do these steps, and you'll be able to factor. I'm going to write in red all day today because I know this is great stuff. Step 1. Step 1. Write big like me. At least 2 lines. At least 2 lines, you're going to write step 1. I wasn't even consistent. I wrote in big letters all the way across. I'm even going to get out my highlighter, and I'm going to highlight that in orange with the big giant highlighter I've got there. Common factor first. Common factor first. Doesn't matter what level of math you're doing, always look for a common factor first. If you're thinking, I don't even know what a common factor is, I know, I'm not done talking about it, but this is what you look for first. Every time you have to go to factor something, first look to see if there's a common factor. So I've got 1, 2, 3 examples, each one a little more difficult to give you an example of how to look for common factors. Examples. Number 1, I chose 14x plus 49. I was hoping that was big enough numbers to stump some of you and convince you that some of the battle in factoring will be how good your multiplication tables are. Yeah? After the test tomorrow, you may want to just get an app on your phone and work on your multiplication tables. Because we're supposed to be, if this is going to go quickly, or at least it's not going to take forever, we're supposed to be able to look at 14 and 49 and see if there's a number that is common or divides into both of them. Did I give you enough time to think it out? What number is it? 7. If you're out there right now thinking, well, this is the problem I have with these, not too good at my multiplication tables. Well, I'm sorry to tell you this, but that's just practice. You didn't practice it along the way. You might want to. You're going to save yourself a lot of time. 15 minutes a day on your multiplication tables is probably going to save you half an hour a day on your homework. That's how crazy it is. So to common factor, we say, well, technically there's a 7 inside of both of those. So I pull a 7 out front, and then I decide what's left in the brackets. Now you could just think it out. You could go, okay, what do I multiply 7 by to give 14x? You could do that. I don't think you're going to find that the best way moving forward. In your brain, you're going to go, okay, take 14x and divide the 7 out of it, because I pulled the 7 out of it, and you're going to go 14 divided by 7. It also gives you something to do on your calculator if you can't do the numbers in your head, if your multiplication tables aren't strong. 14 divided by 7, which is 2. And then 49 divided by 7. Divide the 7 out of that as well. I put the 7 out front there, and I get plus 7. So there's good news about this lesson. I'm going to give you a procedure. Here's how you factor. It's going to be like a recipe to make pancakes. Do this, then do this, then do this, and you'll be done factoring. The bad news is 11U, this course, doesn't do a great job of telling you why factoring is so important. So I'm going to do my time machine example. I'm telling you, if advanced functions version of you came back in a time machine and was sitting beside you, and calculus version of you, or first year university version of you, came back and they were sitting beside you, they would all slap you in the head right now and go, pay attention. We're going to use this again and again and again, and it's going to matter. That's why we do a whole chapter of it. I'll do another one. And again, you can use this guide. You can put it on the, some of you aren't doing a great job Like someone will ask me a question, and I'm there to help. Someone texts me a question, I want to help you. But I'll look at someone who asks me a question, I'm like, this question you're asking me is exactly like the one I did on the board. You're not using your notes well enough. Yeah? The notes are there for you to look at and go, ooh, did he do one like this? I'm not saying don't bug me. It doesn't bother me. I'm not annoyed. I'm just like, oh, I've got to teach them that the notes show you how. When you go to do this homework, have these notes out. Don't just snap them into your binder. Have them sitting there to look at. Here's the next one I came up with. The first one acted like all you got to do is look for a number. That's not true. Common factoring means look for anything that is a common factor to both. And now I'm using all the words, common factor. So yes, look at the coefficients. I've got a -2 and an 8. Is there a number that divides into both -2 and to 8? 2 divides. I might stop for a minute and go, should I pull the -2 out? Is it -2 I should pull out? Moving forward, the answer is yes. It's not wrong to just pull the 2 out. But, and again, 11U does a bad job of proving why you want to do these things. But if you get a chance to pull the negative off the front one, you're going to like that better. Yeah? So when the negative's on the front one, then yes, pull -2 out front. It'll be easier to manage the negative when it's out front like that. So who remembers common factoring? What did I forget to do on this particular example?
Could you take backs with it?
Yes. So common factoring isn't just take out the biggest coefficient, it's also take out the biggest power of the variable, in this particular case, x. So the biggest power I can take out, this one's x squared, this one's only x, I can take an x out of both. I'll give you a hint that 11U doesn't do a good job of as to why we're doing this. We're trying to make this into something simpler we can manage. -2x squared plus 8x is a fairly complicated expression. But -2x isn't. I can deal with that by itself, and that's not as complicated. We're actually going to try and break this problem down into 2 pieces. All right, so what's left here? If I take -2x out of -2x squared, well, the -2 is clearly gone. I've dealt with that. But if I take x out of x squared, how much x is left? Yeah, just x to the power of 1. I'm dividing that x out, so I'm subtracting the exponents there. Then this part. 8x, positive 8x, divided by -2x, that would be -4. Look at how simple each of those 2 brackets are. That's what factoring is about, is to make 2 simple brackets that I can manage. I'll put this over there. Do a third example. I think most of them I do 3 examples. And to get your brain ready, I only have 4 steps. There's only 4 steps to this, with some examples to think about under each one. So this won't take up your whole period. You have some time to work on review if you're panicking about review, which you should be. Here's the craziest one I came up with for common factoring. Could there be crazier ones in the homework? Well, I suppose so, but we're not really setting our goal at getting insane here with these things. So, just like the last one, I like looking at the coefficients first. I just look and go 10, 25, and 15, and sometimes it's easy. But I chose this one on purpose as a lesson to you people who aren't very good at your multiplication tables. If your multiplication tables are good, this is pretty straightforward. See, 10, 25, and 15 is supposed to be pretty easy. You're supposed to be like, that's 5, right? But 14 and 49 was supposed to be easy too, if you know your multiplication tables. If you don't, this stuff takes forever. You're sitting there on your calculator punching, trying to come up with these things. Just practice your multiplication tables. It'll serve you well. So I took 5 out of there. Then for the variables, I go, what's the largest x power I can pull out of there? I look and I go, 4. Can I pull out 4? X cubed says, no, can't take 4. I've only got 3 on my power, and then this one's only got 2, so it's x squared is the biggest power you can pull out. So common factoring is find the biggest coefficient you can pull out, then find the biggest power of the variable you can pull out. Why do we do it? Because it's going to make the brackets simpler. It's going to make the individual factors simpler for us to analyze and figure out what's going on. Huge Huge. Maybe 10 Academic teaches it a little bit. You did factoring quadratics to find the zeros and stuff like that. You did a little bit of why this is important. This is complicated, but now this factor isn't so complicated. Okay, coefficients you just divide. 10 divided by 5, now I'm down to a 2 there. Variables you also divide. X to the 4th divided by x squared, but when we're dividing powers, we subtract the exponents. That was what chapter 1, part 1 was supposed to get through to you, is that you treat numbers and powers differently. You're not actually doing different math. I don't want you to think there's different rules. But because something has a power, it's a different process there. All right, what's the next one? I took out 5 out of 25, so 25 divided by 5 is 5. And I took x squared out of x cubed, so 3 minus 2, I'm down to just x. And the last one, negative 15 divided by 5, I got negative 3, and I took all the x squareds out. Nice. This came out to a nice quadratic. Now, if you're right with me, I'm going to highlight that as potential danger. We're going to have to come back. So leave a line there, because that might not be done. But I haven't taught you the step I need to. I put this one here on purpose. We're going to have to come back and check this. Don't let me forget, after step 4, to come back and check that crazy thing. No, but she's not here to carry you guys through life, are you? No. Look at, happy birthday. Oh no, that was for you. You can give away all your old ones to them. Use the new ones. Don't give them your new ones. Give them your old ones.
Mr. Todd, I came prepared to class. I have 3 colors.
It's fun, isn't it?
Oh yeah.
I got more sets there. I'll give them to you too. I can't believe you didn't keep the new ones. She says, look at, you're attached to yours, aren't you? You're like, no, I like mine. Thank you very much. Okay, don't forget, please, don't forget. At the end, Miss Todd, go check that last one, okay? Because that's part of the problem with factoring. If you mostly understood factoring, but the factoring test came up and you did bad, you needed my guide. You need my guide, that's all, to factoring. Next. Step 2. Step 2. Phrase this carefully, Mr. Todd. Say this carefully.
Excuse you.
Is it a 2-term polynomial that is left? After you look for a common factor, do you have a 2-term polynomial? Again, if you had trouble with this on the test last year, you're going to be angry in just a second and go, these are the exact steps I needed to think this through. Next, 23 years of experience saying, next, see if it's a 2-term polynomial. If it is, write all this down. If yes, check for difference of squares. Now, I'm going to do a great job of teaching, a good job of teaching difference of squares, but maybe not a great job. This lesson isn't designed to teach difference of squares from the fundamentals. The idea is you've sort of seen difference of squares before, but maybe you just don't quite remember how it all goes. Okay? Example. Oh, I didn't want 36. I wanted 25. Difference of squares. Difference of squares. Okay, so you check, is it 2 terms that I'm dealing with? And the answer is yes, 2 terms. So I'm going to check, is it a difference of squares? And what I mean by that is truly difference of squares. Is it a difference? Is it subtracting? Yes. So this one, I'm going to put a check mark under the difference going, yes, Maybe this is a difference of squares, because it is a difference. Next, are they both squares? Is x squared something squared? Well, obviously x squared is something squared. But is 25 something squared? Yes, it is. So this is a difference of squares. Now, I don't know how much you remember about it, and I'm going to explain it here, but I'm going to explain more of it on the next slide if you're like, I don't really get why that happens. Difference of squares is the easiest of the 4 steps. If you know what's happening, if you're going, this is difference of squares, it's this simple. The first set of brackets is x plus 5, and the second one is x minus 5. Where are the x and the 5 coming from? Well, what was squared to give 25? A 5. What was squared to give x squared? An x. Now, why does it work? Why does it work? Let's talk about why it works. And the conjugate is sitting right here going, this is just like the conjugate. That's what difference of squares is. That's why we use the conjugate, because it produced a difference of squares. Let's go over here and just check this out in another color. Let's see why this works. FOIL, x times x, x squared. See, that's why I had to use x and x, because x times x is x squared. Then something upsetting happens. X times negative 5 is negative 5x. And if you only check that much, you might be like, Ms. Todd, your difference of squares thing does not work, because the initial one did not have x's, but when you FOIL it out, yours does have x's. I nod and smile and say, keep going, keep foiling. And then you FOIL here and you go 5 times x, positive 5x, and your brain blows up. You're like, oh, that's why difference of squares works like it does. By doing positive and negative, the two OI terms of FOIL, the O and I, cancel out. And all I'm left with is FL of FOIL. That's what difference of square is. Is it like, well, what if it's FL? Yeah? Because the OI cancels. And then here I get 5 times negative 5, which is negative 25. Do you see it? It's the easiest one. And the easiest one to understand, too, where you're like, oh, if it's a difference, it only works for minus, and they're both squares, use the square roots, do plus and minus. It's conjugate. That's what it is. It's the conjugate from last chapter. That was example 1. Does that ring a bell? Sometimes in 10 academic, this gets left behind because we got bigger problems coming. So we focus on the bigger problems and we leave the easy stuff behind. But I think this is the easiest of the things out there. More on this on the next slide. If you're not quite sure why it works, more of this on the next slide. So sorry, I've selected perfect example, so I'm just going to look at my sheet to get a perfect example here. Oh, yes. Yes, yes. Perfect example here, 4x squared minus 9. Here's how you use my perfect guide. You first go, is it 2 terms? Yes. 4x squared minus 9. Is it 2 terms? Next, is it a difference of squares? Let's check. Is it a difference?
Yeah.
It's minus between. That's what difference means. It's minus between. Are these things both something squared? Is there something squared that I can get to give 9? 3. Is there, oh, big moment here. Is there something squared that gives 4x squared? See, both the coefficient and the variable have to be something squared. 2x squares to give 4x squared. And now we're ready to go. Like, I'm done. At that moment, if I identify that as difference of squares, by the time you identify it is difference of squares, you're basically done the question. 2x plus 3, 2x minus 3. And if you're skeptical, do the do the FOIL. You'll find out there's no OI, because these are conjugates. And you'll end up with FL, which is 4x squared minus 9. Yeah? Do you have questions? Most important example, I think, on the whole lesson coming right up now. So if you only have 47 seconds of attention span, no, it might take a little longer than that. If you only got 2 minutes of attention span the whole day, you might want to use it right here. 2x to the fourth minus 242x squared. Is this two terms? Yes, it's two terms. So you might believe it's difference of squares. You go, is there something that squares to give 2? And there's not. Is there something that squares to give 242? There's not. And this is in your homework. You're like, yeah, what? What am I supposed to do here? T, you send me a text going, it's not difference of squares. You said the two term ones would be difference of squares. Always, always, always common factor first. In fact, when I teach advanced functions, which I don't have one, I literally write on the board in the back there. It's on big letters at the back, common factor first. I just leave it up there the whole semester. Because there's questions out there in all levels of math that seem so ridiculously hard, but if you just common factor, everything will be fine. Yes? Common factor first. For those of you watching this on a video, I've now gone back and put a star beside this. You were unimpressed when I wrote in big letters, like, oh, Ms. Todd, silly, you wrote in big letters. No, no, no. Ooh. Common factor first. Yes? Back to this thing. That's why this guide's so important. That's why maybe you had trouble in 10 academic with this. First look, is there a common factor? Is there something that divides into 2 and to 242? 2. The biggest exponent I can pull out of this? X squared. I'm doing this a little faster than the previous page to get to the point of this example. Divide 2x squared out of x to the fourth. I get x squared. Take 2x to the fourth out of 242. That's not on my multiplication tables. If it's not on my multiplication tables, yeah, go to your calculator. 242 divided by 2 is negative 121. It's a perfect example. Now I have two terms. Is it a difference of squares? It's a difference. X is squared, but is 121 something squared? Maybe the numbers get too big for you. It's 11. X and 11. So it's 2x squared times x plus 11 times x minus 11. Oh, that's the problem. See, the way we teach it in 10 academic can mess you up. We teach you common factoring, and you go home and do 100 common factoring questions. Good. Then we teach you difference of squares, and you do 100 difference of squares questions. And in the test, you get one of these, and you're like, what's happening? It's not any of them. I know. It's both of them. But I've given you the order now. My perfect guide says, look for the common factor first. And once you have that pulled out, then you can look for other things. Yeah? Woo! We're halfway done. Well, we're more than halfway done. The last two don't take as long. Do you have questions there? Do you need more time there? Step 3 of 4 coming up here. Step 3. A long sentence with a shortcut coming. But if you're copying this down, write down the long sentence, and then you'll understand what the shortcut is. Step 3. I want to phrase it. Is it a, okay. Is it a 3-term quadratic left? With x squared coefficient of 1. Oh, that's a long sentence. That's not the way most teachers write it. They write it like this. This is the shortcut. Ax squared plus bx plus c, comma, a equal to 1. But do you see the problem with that? And if your algebra skills are you're just working on your algebra skills. So you're only in grade 11. You're just working on these algebra skills. This can be confusing, and yet it says what that sentence does. Am I a quadratic? X squareds, 3 terms, but the a is equal to 1. What do I mean by that? Here, my first example is exactly that. And sorry, there'll just be a little break as I get my sheet because I've selected the examples very carefully to show off lots of stuff here. X squared plus 9x plus 20. Let's ask it both ways so you're ready. Is this a 3-term quadratic with the coefficient out front is 1? Yeah. Is it ax squared plus bx plus c, but the a is equal to 1? Yes, it is. And I'm sorry if I'm messing up here. If it is, use add to b multiply to c. And I'm going to describe what that is in just a second. But I hope you remember this one. Most people from grade 10, this is their favorite type of factoring. They like this one. What I've got to do is unfoil this thing. If this thing foiled out to x squared plus 9x plus 20, whatever these two numbers in the end of the brackets are, they've got to multiply. They've got to do the L in FOIL out to 20. I need two numbers that multiply to 20. But those two numbers also have to add to 9. And by the way, now's when you might start getting a little itchy here, where you're like, oh, we're coming up on the one I don't like. See, you're doing the easy one, Mr. Todd. You're making the a equals 1. What happens if the a is not 1? All right, calm down for a second. These ones, supposed to be pretty easy. What are the two numbers that multiply to 20 but add to 9? 4 and 5. Now here's where the multiplication tables come in. If he came up with 4 and 5 and you're like, I'll just need a minute here. I can get them, but I'll just need my calculator for 3 or 4 minutes here. That's when the homework's going to take forever. If you had to do it, though, you'd go over and go, OK, add to 9. 1 and 8 add to 9. Does it multiply to 20? No. 2 and 7. That adds to 9. Does it multiply to 20? No. 3 and 6. Does that multiply to 20?
No.
No. 4 and 5. Do you see? This is what you're doing if your multiplication tables are terrible, where somebody else is like, they probably can't even explain what they did. I say multiply to 20, add to 9. They go, 4 and 5, I don't know how I got them, but I just know. And the party's over. Why does it work? I'm going to pause for questions just a second. Why does it work? Let's check out the FOIL. The check here. X times x is x squared, and 5x and 4x, and 20. Those two terms, those two numbers at the end of the brackets have to add up to give the 9, but they have to multiply to give the 20. I saw a hand. What was the question? I ignored it to keep trucking. Is it okay?
Why can't you do decimal?
Oh, yes, a great question. What happens if it's decimal? And I'll give the answer to your question. They're too hard to come up with if it is a decimal.
9 divided by 20.
What's that?
If you just do 9 divided by 20.
9 divided by 20
20
is
divided by 9.
0.45.
Yeah, 20 divided by 9.
20 divided by 9 is 2.11111.
So why
Oh,
can't,
22222,
why can't we just use that?
because it doesn't work.
Why though? It should. No, it doesn't. Are you sure?
Doesn't give the right numbers.
Shoot.
Essentially, we're unfoiling here. For those of you who are having any trouble with this at all, like I remember teaching 11U a long time ago. It's been 15 years ago. And there's one guy who had a terrible time with factoring because of the way I was explaining it. And then the day before the test, he said to me, so Mr. Todd, I just have to find the numbers that foil out to that? And I was like, yeah. He's like, oh, OK, I'm fine then. He didn't like all my wordy stuff. He's just like, just tell me what I have to accomplish. Here's what you have to accomplish. You got to make two sets of brackets that foil out to that. But to do that, you're looking for two things that add to the b and multiply to the c. Not bad. OK, let's try another one. X squared. Just looking at my examples because I chose ones on purpose that worked a certain way. Plus 5x minus 36. Is it a 3-term quadratic? Yes. Is the a value 1? Yes. So your life is as simple as what multiplies, oh, that was supposed to be a 36 at the end, sorry. not a 6. There. Your job is as simple as, and I've seen people do it like this. In this situation, they write add over top of the 5, and they write multiply over the negative 36 to remind them that these are the things we're going to need to FOIL. We just draw a line there, not to get confused. And again, just to not embarrass the people who aren't good at multiplication tables, but to inspire them that it matters. What two numbers multiply to negative 36? 6 and that you did the one I wrote down. I wrote 6 here. This is 36. When I wrote negative 6 there, I made a different question. So this has to multiply to negative 36 and add to 5. Nine and 4. Now, she did that pretty quickly. And if you're like, I could never do it that quickly. Here's why. It's actually quite simple. It's not grade 11 math that's causing you a problem. It's grade 6 math that's causing you a problem. You're like, Mr. Todd, I tried. I really did try in grade 6 to multiply them, or to memorize them. Make or print out a multiplication chart for yourself and use those to do the questions for a while. Do you know what a multiplication chart is? 1, 2, 3, 4, 5, 6, 7, 8, 9 along the top. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can find them on the internet, print it out, and you'll have all the numbers there, and it'll help you get through these a little faster. Okay? If it really just didn't work for you. Okay? So she says the two numbers are 9 and 4. I didn't hear her say positive or negative. She might have. She may have. But I'm just going to put the 9 and 4 there, because once you know it's 9 and 4, because that's how my brain works, actually. I go, oh, 9 and 4 multiplies to 36, and 9 and 4 comes out to 5 if you put the adding and subtraction in the right thing. Then it's just like, which way around do I do it? For me, if it comes out to positive, then the bigger number has to be the positive one for this to FOIL out right. And then you FOIL it out. You go, okay, x squared plus 9x minus 4x minus 36. Like, check it. Don't write down the wrong one, because it's easy to get the wrong numbers. FOIL it at least in your head to make sure that these are the right numbers. Any questions on that? Well, wake up for this one. Is this a 3-term quadratic? Yes. Is the a value 1? No. Mr. Todd, why are you putting this on this page?
I listened. I was waiting for the chair.
Yeah, the chair's the best part. Let's pretend you didn't say that. Mr. Todd, why are you putting this in this example? This example, this step you're talking about is a value equal to 1, to which I say, lost all the drama by taking too long here. Common factor first, common factor first. Why am I being ridiculous? Well, because it's fun for me. But also I'm hoping if you're with me in advanced functions or not, doing your homework, all of a sudden you're like, some questions causing you probably like, oh, maybe I'll just check for common factors. I hope you remember this crazy moment. Common factor first. Is there a number that divides into 3, 27, and negative 66? 3 works for all of them. And then I get x squared plus 9x minus 22. Then it's a 3-term quadratic with a value equal to 1. And I can look for two things that multiply to negative 22 but add to 9. Is there two things that multiply to negative 22 and add to 9? 11 and 2. I like how he said that. The way he said that is exactly how I think. I just go, oh, I know it's 11 and 2. Now let's just take a second and get the positive and negative in the right spots. It's got to come out to positive, so I'll need the bigger number to have the positive and the smaller number to have the negative. Let's just review why we're doing this. Look at how simple each of those is. When we go to do some work with this, this will be easy to work with. This will not be easy to work with when we can. Do you have questions there? Do you need more time? We're on to step 4. Going to wrap it up very soon. Step 4. Is it a 3-term quadratic with x squared coefficient not 1? That's the long version. That's the version you look back and like, I don't understand what he's asking there. Most textbooks, most teachers go, is it ax squared plus bx plus c, but the a isn't 1 anymore. And if you didn't like factoring in grade 10 at all, this one is y. I'll go right to an example that I've chosen carefully. And now I ask an important question. What would you look for first in this example? Always check. It could be you already looked at it and went, I know it's not a common factor, but check for that first, because we don't want to have to do this step 4 if we don't have to. It's painful, this step 4. It doesn't have a common factor, and there's a value equal to 2. There are 2 ways. That's a complete lie. There's like 500 ways that nerds have come up with to get out of this kind of trouble. I'll only show you 2. If you learned Magic X last year as the way to handle this, I'm not going to teach it exactly, because I think we can do a little bit better than Magic X. Okay? But Magic X will be laying there in what I'm doing. So if you learn Magic X, I can help you if that's what you like. Magic X is good because it magically gets the answer. It's bad because I don't know why it works. I'm going to show 2 ways to handle this. Okay? Line down the center. Don't choose yet which way to go. The one on the left is for people who are pretty good at their multiplication tables. I call it Jedi factoring until somebody asked me what a Jedi was, and my head almost exploded. Mrs. Malecki calls it use your brain factoring. And what she means by that is like, well, something foiled out. There was 2 sets of brackets and something foiled out to give this thing. But I can look at it and get a hint. If the 2x squared is the leading term, the first 2 terms have to be 2x and x. I'm almost done this factoring already, and I haven't put much thought into it. I've taken care of the f in FOIL. Then I jump to the l in FOIL. I go, well, whatever the last 2 terms are, they have to multiply out to 5. What do the last 2 numbers have to be if they're going to multiply to 5? There's only 2 numbers that multiply to 5. 1 and 5. So the only question is it 5 here and 1 there? Or is it 1 there and 5 there? This might be wrong. I don't know which way around the 5 and 1 go. So then I just FOIL the check. That's why it's use your brain. Like, let me just check. This is what the student I was talking about that I used to teach. Once I told him, just find the things that FOIL, then he was off to the races. You're like, okay, let me check if this works. 2x times x is 2x squared. I don't actually have to check that. I knew that was going to work. I chose 2x and x. Then 2x times 1 is 2x. 5 times x is 5x. That doesn't add up to 11. So I'm just checking the OI. So what does it have to be? This is why people don't like this method. They don't like erasing and going in again. Maybe the 1 and 5 has to go the other way. 2x times x, I'm actually going to write it out this time, equals 2x squared plus 10x plus 1x plus 5. Is 10 plus 1 equal to 11? So if you're decent at your multiplication tables, you might just like use your brain factoring. If you have my class in advanced functions, that's the one I'll focus on. It's like, let's just use our brain, play around a little bit, and unfoil this thing. So I'll label that use your brain. And I don't mean use your brain the way mommy says use your brain. Like, use your brain, don't do that. No, I mean like, you're smart. You know what FOIL is. Just use your brain to get the answers here. Just play around until it works. Some math people don't like that. Like, just play around. That's all you got? No, this is not all I got, but it's pretty good. I like this. This is the way I do it. The other one, which is actually Magic X, is called decomposition. And I'll use that word, and if you're trying to learn about decomposition, because you get to like decomposition, that's what you should look up on the internet to watch videos about it. Go decomposition factoring. So here's how it works. It's a tiny bit magical. It works like this. Find out the value of AC, which here is 2 times 5, which is 10. Then find 2 numbers. That multiply to 10 but add, but, but, don't even start ActiveBoard. But add to 11. What numbers multiply to 10 but add up to 11? 10 and 1. And I'll write that underneath. 10 and 1. I might have lost half of you already over here. You're like, I'm not loving this method at all. I'm going to be over here using my brain, thank you very much. But about half of you might be interested in this. Like, it's got a set of steps to it. Use that to break up the b term. So I'm going to write 2x squared plus 10x plus 1x plus 5. Completely mysterious until I say this. I've done one step of the unfoiling here. That's what I've accomplished. This procedure allows me to unfoil this thing and find out what was it before someone put the middle terms together. Then how do I find out what the 2 brackets were? I'll call this double common factor. What? Double common factor. I'm going to common factor the first set and the second set. So it's 2x, x plus 5, and this one doesn't have a common factor, so I write a 1 out there. And there's the 2 brackets. Can you see them? X plus 5 and 2x plus 1. Which one was faster? Which method was faster? Use your brain is way faster. It's not even close. But decomp, very popular because it handles big numbers, it handles any situation, and just moves the way through it. But it's a bit mysterious. If you only understood it about 50%, that's pretty good for our first time through with decomp. Let's not wait around to this weekend to find out that those are difficult for you. As soon as you're done copying, I'm going to put one up on the board, and I want you to give it a try. I've got 2 examples left if your brain is fried. More time here? Okay, so here's my example that tests out how you are at this. 3x squared plus 17x minus 6. It does not have a common factor. So you either need to use your brain or decomp. Take a second and see if you can figure out what the 2 brackets are using either method, and I'll do both methods in just a second. Take that back. I wanted you to have some time, so this will be the last example. Yep. It's 3x squared plus 17x minus 6, but I'm just going back for a second. Oh, I just remembered why this is the last example in my notes. I got to go back for something, right? That's where it is. Okay, good. Okay here now? Yeah? Any luck? Does anyone want to talk about it? More time? Do you want more time to try this thing? Who wants more time? No, you're okay? Who's got the answer? Let's start there. Let's find someone who's got the answer, and then we'll ask them how they did it. Well, I'm going to draw the line. I'm going to do it both ways. One more time. Did you get the answer? What do you got?
I got 3x minus 7, and then multiplied by x plus 1.
X plus
1.
1. Now, he's either right or wrong. And when you do these yourself, I encourage you to check them. He's in pretty good shape. 3x times x is 3x squared. 3x times 1 is 3x minus 7 is not 17. He's off to a good start. It needs a little more work to get the right numbers, because negative 7 times 1 is not negative 6. But that's how to do them, is you write something down and you multiply it out and see what works. So if you're using use your brain method, I think he's on to something there. 3x and x are definitely the two numbers that this thing starts off with. She likes 3x subtract 1, x plus 6. Did you use your brain? Yeah, when the numbers are bigger. See, some of you after my first example were like, oh, I'm going to use my brain. I'm like, yeah, I gave an easy one, the first one. Might have convinced you to use your brain, but you got decomp out of this. Could you do it with use your head? Yes. You could have gone, okay, multiplies negative 6, so 1 and 6, 18, 1. You got to be good at your mental math to do that. With decomp, here's what you do. You find out what AC is. 3 times negative 6 is negative 18. Then, you find out two things that multiply to negative 18, but add to 17. So 1 and negative 18. Oh, negative 1 and 18. It didn't take me long to find them. Did you go negative 1, then 18, or 18, then negative 1? I want to do it the same as you. 18, then negative 1. It just changes the procedure slightly, but not much. So you use that, those two numbers, to break up that middle term. It feels like cheating, but it's not. It's just saying, what was this before it was FOILed? And this helps you find out what was it before it was FOILed. Then you common factor each pair. What was the common factor here? 3x. X plus 6, yes? And then you got to common factor the negative 1 to get x plus 6. And then you're supposed to be able to see the brackets after you've done a few of these. You can see the first bracket is x plus 6. The other bracket is 3x minus 1. A bit mysterious and difficult. That's a difficult example, so don't be too hard on yourself if you're like, huh. And then here's what you do in a math lesson. You go and do all the homework for the other ones first, and you go, okay. And then you come back and relook at these notes, relook at the video, and go, okay, let me go after these ones where a can't equal 1. And you're not too hard on yourself. Well, those are difficult. Any questions about that procedure? What did you learn last year on these? Do you remember what you did? Magic X? Magic X people out there? This is essentially Magic X. It's just a little more, it's a little less magic. You get to see what's going on here. Because the Magic X does this AC thing as well. It does this as well, but it doesn't break it up like this. Here you get to see why things are working like they do. I just skipped over those questions. I didn't even care. Well, that's not going to work this year. You got to get this narrowed down. All right, so now's the time to practice this, and there's a zillion practice questions. However, I want to go back to that initial one. Back on the first page, and I'll go back to the last page if you want it. See what happened here? I common factored, but ended up with a quadratic with 3 terms, coefficient not 2. So then sometimes this factors. Let me show you, use your brain one more time. If it's 2x squared, this has got to be 2x and x. If it's negative 3 as the last term, I need 1 and 3. Let's see, if I put the 1 and 3 there, I get 6 and 1. Ooh, that works. So now I'm coming back the other way going, if I started off by use your brain, you're like, I'm going to use your brain. And then the second example, like, oh, I better use decomp. Maybe this one comes back a little bit. Maybe I can work it out. If this was a plus 3, that would be 6x. And then that was a minus 1. That would be the negative 1x. And that's as use your brain as it looks. It's just me going, what would FOIL out to this? And just playing around with the numbers until I find the right ones that FOIL out to it. Question? Here? No. No. You don't need to show your steps here because if you're not using decomp, if you're using use your brain, there might not be much to show. Except a bunch of eraser marks as you go, oh no, the 3 goes there, the 1 goes there. You're just playing around with it. Okay? Yes, ma'am. All right. With practice, these get better. Of anything in math. I know that factoring is just pure practice and everything will be fine.